Let's find the extrema using Lagrange multipliers. F of x, y, z equals 3x minus y minus 3z. So that's, F is what we're trying to optimize. And then the two constraints are x plus y minus z equals 0, and x squared plus 2z squared equals 1. Okay, so it's pretty important that you realize this guy on the left here, we could call that g of x, y, z. And if we set this guy equal to 0, x squared plus, not that it really matters here, 2z squared minus 1 equals 0, we could call this guy h. H of x, y, z, even though you don't see a y there. Just to be clear, we're thinking of this as three inputs, a three-input function. And this is a three-input function. Okay? So let's write down the result once again. Del f is equal to lambda del g plus mu. Sounds like this. If you crossed a cow with a cat, what sound would it make? Mew. Yeah? All right. I made that joke up myself, you can tell, huh? It's a cat cow.
This is what happens when you spend a day in kindergarten.
Yeah, well, it's just what happens after 8:30 at night. I get silly. What?
Really weird milk.
Yeah, I'm not sure I'd want that milk. All right, let's hold it together. Just this example and one more, and that's it. Let's hold it together. So del f, what would that be? So focus your eyes on this guy. It's not a bad one. 3i minus j minus 3k. Oh, that's the easiest one you've seen yet. And then del g. Okay, so, well, just del g would be 1i, or just I, plus j minus k. And then, yeah, if you wanted to, you could put the lambda in all at once. For some reason, I don't like doing that, and I'm not sure why. But I don't care if you do it. And then what would del h be? 2, oh, I'm going to leave space there for the mu. Mu. Plus, yeah, and let me line it up. So plus 0j, right? So I'm not going to write it down. And then plus 4zk, lining up the correct components so we don't misjudge something. And then we'll use mu here. There we go. So here's how you set up the system in this case. Well, let me shrink it. Just enough so you can still see it. But I can create my system right here. So, okay, let me circle the 3. That's the guy that's going to be on it by itself on one side. And you would say 3 equals, okay, this component, the component of lambda del g, plus this component, the component of mu del h. So 3 equals lambda plus 2 mu. Does that make sense? That's what you would get if you add, for the right side, that's what you would get for the I component if you added lambda del g with mu del h, right? That's what you'd get. And so you're going to set that equal to the I component of del f, which is just 3, right? Because to add vectors, we add corresponding components. Question? Probably. Yeah, I got it so small, my old eyes couldn't see it. You're right. There's an X right there. Everybody see it? Okay. And then what? What are we going to have? Oh, -1 equals just lambda, because there is no j term for mu del h, right? Okay, and then what? -3 equals the negative lambda right there, and then 4 mu z, plus 4 mu z. Okay, everybody with me? And finally, 2 more equations. What are they? The constraints, yeah, x plus y minus z equals 0. And just, I'll write the original form of the second constraint, x squared plus 2z squared equals 1. Oh, joy, we got 5 equations. I know. But it's not as bad as it looks. Lambda equals -1. Come on, that's not bad. Stop complaining. Okay. Back in WW2, we had to solve 30 equations and 30 unknowns. What? Okay. If I put, I'm going to save some space here. If I put a -1 in there and add it to the other side, what do I get on the left side? 4 equals 2 mu x. Does everybody agree with that? Everybody see what I did? Okay, let's do that for this guy too. If we put in careful here, a -1 here, opposite of -1 is a +1. Then we subtract it. What do we get on the left side? -4 equals 4 mu z. Everybody with me? All right, let's make these guys a little bit easier on the eyes by dividing out the 2. What do we get? 2 equals mu x, and -1 equals mu times z. So everybody agree with that? Okay. So that's nice. It's 2 equations, and, 3 unknowns, I suppose, right? But it could be worse. Could be digging ditches. So what could we do here? Couple of options. We could solve for x and z in terms of mu. You want to try that? Yeah. So do we have to worry about mu equaling 0 here? No. I mean, you could get it from other spots, but if mu were equal to 0, this whole term would go to 0. Then you'd get lambda equals 3, but we know lambda equals -1. It'd be a contradiction. So it's okay. You could divide both sides by mu if you wanted to, get x in terms of mu and z in terms of mu. You want to see if that works? Or you could get mu in terms of x and z if you want to stick with x and z. It's up to you guys. What do you want to try? You want to stick with x and z? Yeah, all right. So what would, going sideways, what would x equal? 2 over mu. And then it actually conforms with what I said, because I said we divide by mu, right? Oh, no, you wanted it in terms of x. Well, let's see. Do we get a contradiction if we divide by x? I mean, in other words, could x be 0? No, x can't be 0 because then you get 4 equals 0, right? So it's a non-issue. We're just tired. Okay, so if you want to do it the other way, we can. And let's see what happens. So you want mu in terms of x then? So you get mu equals 2 over x. Yeah? And don't have to worry about division by 0 here. We already showed that that's not a problem. And then likewise with the z, what do you get? Mu equals -1 over z. Huh. There's a problem though doing it this way. I'm gonna overrule you, if that's okay, because wouldn't it be nice to plug into this last equation if we know x and z in terms of mu? But you know what? That's going to happen all the time in the homework. You're going to go in one direction, and then you're going to realize, oh, maybe I should have tried it this way. Go ahead and try it that way. So, yeah, I'm going to overrule you. Sorry, I didn't mean to. Usually I like to do what students tell me, but I don't think so. So how about x is equal to what I said originally, 2 over mu? And then what would z equal? -1 over mu. Now, just to make sure that's clear why I did that, I know what x and z are in terms of the same variable. I've got an equation in terms of x and z. I can get that in terms of one variable, right? So let's try that. So if I take this last equation, what am I going to get here? If I plug in this guy for x and square it right here, I get what? 4 over mu squared. Yeah, so plus, and the negative will square out, so that will be 2 over mu squared equals not mu, but 1 is what you meant to say, right?
Yeah. So,
And then that gives you 6 over mu squared equals 1. Nice.
so 6 equals mu squared?
No, now, the only reason I'm going sideways is because it's useful to stay in one screen, but if you guys want to work down, that's fine. So mu squared equals 6. Does everybody buy that? We're not actually looking for mu, right? Or mu squared. This is just a means to an end. So if I know that mu squared is equal to 6, what are the possibilities for mu? Plus or minus root 6. So now I'm going to want to go back to these two. And I got x and z, don't I? Does everybody see that? So we do have to be careful here. So let's look at the case where mu is negative root 6 and the case where mu is positive root 6. So if mu equals negative root 6, let's make that one case. What does, looking at this equation, what does x equal? So there you go. So x equals 2 over negative root 6. And what does y equal? Sorry, z.
No.
Excuse me.
Negative 1 over negative root.
You're all what? Yeah, because we're plugging in this one, and that's z equals. So negative 1 over,
Negative root 6.
well, but we're plugging in negative root 6, though, and it's negative already.
So 1 over
So 1 over root 6. So do you guys see what the critical, well, do you see how we can get the full critical point? It has to include a y value. So which equation haven't we made use of yet? Okay, so x is negative 2 over root 6. So I'm plugging in this one. Plus 1 over, well, that's plus y in the middle there. And then minus 1 over root 6. And then equals 0. Does that make sense? And then, so what is, if you combine these together, it makes minus 3 over root 6 on the left side, right? But that makes y equal to 3 over root 6, doesn't it? Does everybody see that?
But if you move z over, you get x plus y equals z.
Let's see, if I add negative 2 over root 6 plus a negative 1 over root 6, don't I get minus 3 over root 6, but then I add it to the other side, don't I get plus 3 over root 6? Does everybody agree? Okay. So then what's my critical point? Yep. So let's just make a point out of it. So the x value is negative 2 over root 6. I shrank it pretty far, so check my old eyes on this. 3 over root 6, and then 1 over root 6. Is that what you guys have? Okay. Now, what's the other case? Mu equals positive root 6. We'll get something similar, but opposite. So, okay, again, look back up here. So x equals 2 over mu, positive root 6 in this case, right? And z equals what? Negative 1 over root 6. So the exact opposite of what we got. You might suspect the y value will be the opposite, right? Let's see if that's the case. So x, 2 over root 6. So again, plugging in this one. Plus y minus z, which will make it plus 1 over root 6. Yep. Equals 0. So we get y equals negative 3 over root 6. Your suspicions proved correct. And then the critical point is the exact opposite coordinates of the last one. So 2 over root 6 for x, negative 3 over root 6 for y, and negative 1 over root 6 for z. Now, believe it or not, we exhausted all the possibilities, though, didn't we? So that's good. And so let's try and remember what the original function was. 3x minus y minus 3z. Let me write it down. So we're going to plug in both of these values. there's no reason to make a table, right, when you only have 2 points. So we're just going to do it. We're just going to find the f values individually. So negative 2 over root 6, comma 3 over root 6, comma 1 over root 6, that first critical value. So what do we get? 3 times the x, what's that? Negative 6 over root 6, minus 3 over root 6, and then minus 3 over root 6. Did I do that right? So, yeah, negative 12 over root 6. If you rationalize, it'll look a little nicer, but who cares? And then plug in the other one, f of 2 over root 6, negative 3 over root 6, negative 1 over root 6. Is it going to be positive 12 over root 6 then? Yeah, because you'll get positive 6 over root 6. And then the minus, okay, yeah, plus. I don't know why I'm double checking. Probably because I'm tired. I just want to make sure. So definitely 12 over root 6. I'm not sure at this point, but I'm pretty sure a positive is bigger than a negative number, right? So what's this guy? Absolute max. And this guy is your absolute min. Whew. All right.